right, friends, here is part 2, and sorry, got cut off in that last video, but in case you didn't see, there's the rest of that graph there. I just plugged in the 1 to get that starting point. I plugged in the 4 to get that ending point, and we go from there. All right, so same idea. If we're going to write that, let's go ahead and first we need to identify all of the different parts, and we're going to essentially write an equation for each section of the graph. So in this case, these are all linear. So I'm going to start with the pink one here. And because it's linear, right, we want to follow this format of y equals mx plus b. So that means that I need my slope. And I can see that here my slope is I'm going up 1 over 1. So my slope is 1. Now, I could just continue the graph to find the y-intercept because that's pretty easy to do, right? And I can find that it's 4. Or remember, this x and y stand for any point on the line. So I know that when I plug in 1, 2, 3, negative 4 for x, I'm supposed to get out a 0. So that's also going to allow me to find my b value. And so I end up getting negative 4 plus what gives me my b value, which is my y-intercept. I get b. So that means that this first equation here is 1x, or just x, plus 4. So that was that pink one right here, okay? Now the yellow equation is just a horizontal line, which means that the slope is 0 and my y-intercept is 3. So that means that that equation is just going to be y equals 3. It's a constant, all right? And then for the last part, we have to take, again, a look at that slope. Now, we do want to be careful. It looks like that's a clear point, but if we actually were to count, we're going down 1, 2, 3, and over 2. So in this case, my slope is negative 3/2, and I'm starting on my y-intercept, which is at 3. So what we want to do is, now that we have those 3 equations, we're going to go ahead and pretty much just stack them, but we have to put some boundaries on them, okay? So we have f of x is equal to these 3 equations, right? It's y equals x plus 4, but it's only when it's between these values. So we have to represent that. So it's between negative 4 and negative 2, and it can equal negative 4. So we have negative 4, right? My x value can be between negative 4 and a negative 2. Well, it can be greater than or equal to that, but it cannot be equal to negative 2 because of that open circle, okay? And so now I'm going to put my next equation here. Well, it fits this rule when, again, notice where does it start? It starts here at negative 2, and it can equal it. So we're going to have the equal to sign. And then it goes all the way to 0. Now, here's the catch, right? We're not sure, like, okay, so is that colored in? Is it not? It all depends on how you want to see it. You can either include it for this equation, or we can include it for the next. I'm going to go ahead and just say that it's included for this particular equation. So I'm going to put equal to 0. So when x is 0, my y is going to follow this particular rule. And then I'm going to write my third rule, which is negative 3/2 x plus 3. And again, because I already included when x is 0 with that previous equation, I'm not going to have that inclusion sign, the equal sign there anymore. I'm just going to go ahead and say that it has to be greater than 0. Even though it's true for both, we have to be consistent. Like, it's going to equal here, but not here. Okay? And then, so we're going from 0 until x equals a positive 2. So it can be any value less than or equal to a positive 2. Okay? That's a 2, not a 1. All right? And that's how you write a rule for a piecewise function, is you have to break it down into its parts and identify, is it linear, is it quadratic, it might be exponential, right? So we kind of want to think about that when we're looking at that. All right? Okay, moving on. If we go ahead and move on to example 4. Oops, sorry. Okay. All right, so this is what is called a greatest integer function. It's also sometimes called a step function. And basically it's just saying it gives you the greatest integer. So like it's the best way to say it and like how to define it, okay, it gives the greatest integer. All right, and so this symbol, right, this little bracket symbol is letting us know what's the greatest integer. And here's the rule. It has to be less than or equal to whatever's inside that, what the x value is. All right, and we'll take a look at this. And so our domain is actually going to be all of, our domain is every single value. Domain is all real numbers. So we can say all real numbers. But our range is actually, notice the gaps, right? It's just the whole numbers, the positive and negative whole numbers, which are the integers. So it's the set of integers. So that's what our range is going to be. So this is where we call that step function. So how do we evaluate that? So what exactly does this mean? So for example, if I'm doing when x is 2, so this is what it would look like, okay? What is f of 2? And so we would plug in a 2 here. And so essentially it's saying, all right, what's the greatest integer that is less than or equal to this value? Well, in this case, it is 2. The answer is 2, okay? That's easy when it's already given to you as an integer, okay? But if we take a look at the next one, we're going to go ahead. So if we see these brackets like this in this function notation, it's asking us, so let's take a look at this number, right? 3/2. That's the same as 1 1/2. So what's the largest integer that this equals without going over? It has to be less than or equal to this value. So we can't say 2 because that would be greater than what's inside those brackets. So in this case, the answer would be 1. It always has to be less than or equal to the value inside those brackets. So if I'm asking you for -2/3, right? Again, notice this value, all right? What's the largest integer? So we're looking for a number that's less than or equal to -2/3. Right? We don't want to say 0. 0 is actually greater than the negative number. So we're actually going to think about it like rounding. If we had to round down to the next whole number, what would it be? So in this case, this would be a -1. All right? And then that last one's already an integer. So if we did that, it would just be itself, which is -5. All right. Well, hopefully that gives you a good idea about what we talked about in class today. And then we're going to be working on for today and a little bit of tomorrow, wrapping up page 85, numbers 1 through 16 in your textbook. So if you stop by and pick up the handout from me, you'll have this directly on there. Otherwise, you'll need access to your book. Make sure you just pay attention to what the directions are asking you and refer back to the examples that we did. All right, and then on the back, we're skipping a few problems. I'm asking you guys to do 21 and 22 to graph those piecewise ones. And then 23 to 28, we revisit the idea about how to write a function rule. So here you'll see 23, 24, and 25. Remember, those go back to our absolute value rules and the whole idea of the transformations. So if you watched yesterday's video with that about, okay, how do I figure out how to write those rules, right? We're looking at something like that, the whole left and right kind of deal and moving up and down, okay? And then don't forget about checking for any stretches and compressions. And then 26, 27, and 28 are what we just modeled here in, I think, what example was that? That was in example 3 from our notes, was how do we write a piecewise function for those, okay? And hopefully when you return, this is all also stuff, and you can check out Delta Math and the videos that they have there to support you as well. All right. Come and see me during study hall if you have more questions.